So, good morning to one and all. Now, in the previous lecture, we have discussed how to draw the influence line diagram for the shear force, bending moment, and the support reactions. As we know that the another application of this ILD is to find out the location of the load, where we are getting the maximum bending moment or maximum shear force, maximum negative or maximum positive shear force, like that. So, in the same category, we have discussed the few problems. Here, what is given? A beam AB of span 12 meter, and over this beam, over this girder, two loads, moving loads are there, and the distance between the two moving loads is 3 meter. One load is 50 kilonewton and another load is 100 kilonewton. Okay, locate the position of loads for maximum shear force and maximum bending moment at 5 meter from the support. Consider any load can lead the other. For example, sometimes the vehicle is moving from east to west or west to east. In that case, this position of the load may be changed. Say, if this moving in 150, it can move like this, and then we can change the direction. Again, it is 50 and 100, like that. Okay, and therefore, on the basis of this, we have find out the location of the load. Here again, we can draw the shear force at a distance of 12 meters. So let us start the problem. The problem again is very simple. First of all, we can draw the shear force diagram. Here, actually, reaction is not required, but we can show like this. If I want the maximum reaction at support A, can I say this is 1 and this is 0? This is the ILD for RA. And if the load is provided at support A, that means 100 multiplied by 1, because this is bigger, and then it will be reduces. That's why 100 into 1 plus 50 multiplied by this distance, that gives the maximum reaction component. Similarly, for reaction, that is the maximum reaction for B, repeat the same procedure. RB is 1 and then RA is equal to, at support A, it is 0, 0 to 1. That's why 100 kilonewton load should be provided at B. That's why 100 multiplied by 1, then 50 multiplied by whatever the increment of this ILT. That gives the maximum reaction at B. That means this is the location of the loads for the maximum reaction. Similarly, in our problem, we can find out the location of the load for maximum shear force, negative and positive. Here, this is the example. This is the ILD at a distance of 5 meter and total span is 12 meter. That's why A by L is equal to 5 by 12 and B by L is equal to 7 by 12. Left toward right, it is my negative, and then section to the right portion, it is positive. This is the ILD for shear force. Okay, this is the ILD for the shear force at C. At C, not RA. Okay, so when we require the maximum shear force, when we require the maximum shear force, can we locate the 100 kilonewton over this maximum distance? Because we need the maximum positive shear force. ILD for the shear force at C, but it is maximum positive. Positive maximum, like this. Okay. So when we get maximum, because 100, this is the larger load. 100 multiplied by this 7 by 12 and 50 multiplied by 0.33, that gives the maximum positive shear force. Similarly, location of the negative shear force, what is the location? Can we put 100 kilonewton over this maximum negative increment, vertical increment, and 50 over the minimum? So 100 multiplied by 5 by 12 with minus sign, and 50 multiplied by 0.17 with minus sign, that gives the maximum negative shear force. This is the location of the load, and we are expecting the location of the load after drawing the ILD. And also we can find out the shear force. Okay. maximum positive shear force, maximum negative shear force. Okay, this is the maximum positive shear force, that is 74.98 from figure number 1, and this is the maximum negative shear force, that is minus 50.70 kilonewton, okay, at the given section 5 meter from the support A. Similarly, we can locate the maximum positive bending moment. Here the bending moment diagram is positive. That's why though there is no issue for the negative maximum bending moment. So at a distance of 5 meter, again this height is equal to A multiplied by B divided by L. A is equal to 5 meter, B is equal to 7 meter. So 5 into 7 divided by total span 12, it is 2.92. So this height is 2.92, and we can find out the this height. That means we can put the 100 kilonewton over the large vertical intercept. Okay, and 100 multiplied by 2.92 plus 50 multiplied by 1.67, that gives the maximum bending moment. Here also we have considered the 100 here and 50 here, but this intercept is lesser than 1.67, and that's why bending moment from this side is less. Okay, so this is the maximum bending moment, 375.50 kilonewton. This is the location of the load. Okay, in the same line we can draw the ILD for the another problem. This is the another problem. Here the beam is overhang and three loads are moving over this beam girder. 2 kilonewton, 5 kilonewton, 9 kilonewton, and the distance between these three loads is 1 meter and 1 meter. We can pass this, move this from the C point to the D point. Okay. So again, we can locate the position of maximum positive shear force, maximum negative shear force, and maximum negative and positive bending moment, because the beam is overhang portion. So again, we can draw on the same line at a distance of 5 meter. This is 12 meter. That's why this is 5 by 12. This is 7 by 12. At support B, it is 0. At support A, it is 0. We can extend because this is overhang portion. And from right side, this is also overhang portion. We can extend it. That's why this distance is 3 meter. So this is 3 divided by L, that is 12 meter. And this distance is 1 meter. And this distance divided by total 12, so 1 by 12. This is 1 by 12 plus this is 5 by 12 minus this is 5 by 7 by 12 plus, and this is 3 by 12 minus. This is the ILD for the shear force. And the location, when we put positive shear force, now when we require the positive shear, here also positive is there, but this is 1 by 12, and when we put this load here 9 into 1 by 12, then remaining 2 will be minus, and that's why again the net bending moment shear force is less. But here 9 multiplied by 7 by 12, this is the bigger one. Then 5 multiplied by this height, then 2 multiplied by this side, that gives the maximum positive shear force. Similarly, negative shear force, repeat the same procedure. 9 kilonewton will be put over the maximum negative increment, 5 by 12. Here also negative is there, but this is 3 by 12, which is smaller than the 5 by 12. That's why this is the location of the load for the maximum negative shear force, right? This is the location. Similarly, for the bending moment, repeat the same procedure. This is the location. Here we can find out the height, and maximum load we can put over the maximum increment. So this is 2.92, this is 2.5, and this is 2.08 over 1 meter and 1 meter. This 9 multiplied by 2.92, 5 multiplied by 2.5, and 2 multiplied by 2.8, that gives the maximum bending moment. This is the location of the load. And for negative, here there are two negative triangles for the bending moment. Here 0.59, but this is 1.25, and that's why we can apply the load. This is the location of load with minus sign. That's my 1.25 into 9, then 5 multiplied by this and 2 multiplied by whatever it may be, because this is 3 meter. So we get the maximum negative bending moment. In this way we can find out the, we can say that the ILD for the beam. So thank you very much.